Okay, so we're living in this incredible age of AI giants, right? These models are so powerful, they're literally changing the world around us. But here's the crazy part, the big paradox. For this technology to be really useful to you and me, it can't just live in some giant, far-off data center. It has to run on the device that's probably in your hand right now. So the question is, how on earth do we shrink these digital titans to fit inside our pockets?
To really get the problem, you have to appreciate the sheer scale we're talking about. I mean, just look at this timeline. Back in 2018, we had models like BERT, which was a big deal. Fast forward to 2020, and GPT-3 hits the scene with 175 times billion parameters. You can think of parameters as all the little knobs and dials inside an AI's brain. The more you have, the smarter it can be. And this growth, it's not just steady, it is absolutely explosive.
So what does a number like 175 billion parameters actually mean? Well, let's make it real. GPT-3, which is already ancient by today's standards, needed 350 gigabytes of memory just to store its brain. To put that in perspective, your fancy new laptop might have, 16 or maybe 32 gigs of RAM? This one model needs more than 10 times that just to exist, not even to do any thinking.
Right, so all this mind-boggling power comes at a huge cost. It creates what engineers call a digital bottleneck. And it turns out that in the real world, bigger isn't always better. In fact, it's becoming a massive problem. Think about it. These enormous models need whole buildings packed with servers just to run, and it can cost millions of dollars for a single training session. And because the AI lives in the cloud, every single question you ask it has to travel hundreds of miles, get processed, and then travel all the way back. That's why you sometimes get that annoying lag. It all adds up to AI that's super expensive, kind of slow, and totally impossible to run on the devices we actually use every day.
So, how do we get around this roadblock? Well, the answer is this incredibly clever technique. It's almost like a form of digital magic called model quantization. This, right here, is the art of shrinking.
Okay, so here's the basic idea. Imagine you're a digital artist and you've got a palette with 16 million different colors. Your painting looks amazing, but the file size is gigantic. Quantization is like cleverly repainting that same picture, but using only 256 colors. Now, to our eyes, it looks pretty much identical, but the file size is just a tiny fraction of what it was. We're doing that exact same thing, but with the numbers inside an AI's brain. And this is the fundamental trade-off. We give up a tiny, tiny bit of super exact numerical detail, that's what we call full precision, in exchange for a massive win. The model gets way smaller, faster, and much more efficient. Suddenly, it's something that can run just about anywhere. It's a really, really smart compromise. But you knew this was coming. There's a catch. Of course there's a catch. If you just shrink things down crudely, you can actually damage the AI. As this research paper points out, it can introduce errors and mess up the model's understanding of the world. They call it feature collapse. Going back to our artist analogy, it's like that smaller 256 color palette made the artist blur important details together, making the final painting and the AI a little less brilliant.
And this leads us right to the central challenge. The multi-million-dollar question that researchers all over the world are trying to solve. How do we get all the amazing benefits of shrinking an AI model without making it dumber in the process? The solution is a genuine leap forward. See, the goal isn't just to make the model smaller anymore. The goal is to make it smarter about how it shrinks. And this is where a brilliant technique called mixed precision quantization comes into play. The core idea is actually pretty simple and elegant. Imagine a sculptor carving a masterpiece out of marble. They're not going to use a sledgehammer for the delicate details of the face, right? No way. They'll use tiny chisels and fine files. Mixed precision applies that same logic to an AI model. It treats different parts with different levels of care. So here's the game plan. First, an algorithm scans the AI's entire neural network. Next, it figures out which parts are the most critical, the sensitive layers that are absolutely essential to its intelligence. Then it keeps those parts in super high definition, using more data, more bits to represent them. And finally, it aggressively shrinks everything else that's less important. It's targeted, it's surgical, and it is incredibly effective.
At the end of the day, these advanced methods, like one called MEC-Quant, are all trying to protect something called the model's information entropy. It's a pretty technical term, but it basically just means the AI's total accumulated knowledge, its core intelligence. The whole goal is to shrink the box without spilling any of the precious stuff inside. Now, check out this fascinating data from a research paper. This table shows the accuracy of an image recognition model. The original full-fat model scores an 88.72%. Now, with just standard basic quantization, it gets an 88.69%. That's amazing, a practically identical score in a much smaller package.
But this is where it gets totally mind-blowing. Look at that third bar, the one for the smart MEC quant method. The accuracy jumps to 90.22%. Let that sink in. The smaller, compressed model isn't just as good as the original, it's actually better. It's more accurate. It seems like by intelligently removing some of the numerical noise, the shrinking process literally helped it become a better thinker.
Okay, so this isn't just some weird academic result. This technology has a massive, real-world payoff, and it is completely changing what's possible with AI for every single one of us. Let's look at what this really means. So here's the before picture. Let's take Google's really powerful Gemma model. In its original, full-precision form, it needs 54 gigabytes of memory. That's more RAM than most of us have in our entire computers. And now, for the after. Using 4-bit quantization, that exact same model shrinks down to just 14.1 gigabytes. That is nearly a 4 times reduction in size. All of a sudden, an AI that needed a dedicated server can now run comfortably on a regular laptop. And it's not just about fitting the model on your device. It's also about making it fast. A smaller model means less data to shuffle around, which means faster calculations. For example, quantizing the Llama 3 model boosted its speed by over 50%. That's the difference between a clunky, frustrating experience and one that feels totally instant.
So when you boil it all down, all this incredible science leads to one simple, powerful vision: taking the superhuman AI out of the cloud and putting its power directly into the hands of everyone on any device they happen to own. Which brings us to our final thought. The engineering breakthroughs needed to make AI small, fast, and local aren't science fiction anymore. They are here, right now. This is unlocking a whole new era of possibilities. So really, the only question left is this: what will you create when superhuman AI can run anywhere?